In this lecture, we will learn about representing a graph as a matrix. For a graph with n nodes, it is a 2D array size n by n. For a weighted graph, the array element a at n of n could store the weight. For a non-weighted graph, a at n of n could store true if there is an edge between nodes, and false otherwise. Determining if an edge exists between nodes is simply an array lookup. It could be done in constant time. The downside of an adjacency matrix is that it is space inefficient. An adjacency matrix requires an n-squared element array, so for sparse graphs, much of the adjacency matrix will be empty. For undirected graphs, half of the graph information is just repeated information. In this approach, a multi-dimensional array will store Boolean values, with true meaning that an edge exists between two nodes, and false signifying that an edge does not exist between those two nodes. We will create a class named graph, inside of which will go an adjacency matrix variable, set equal to an empty list. Our graph class is going to have an addEdge function that takes in three parameters: self, I, and j. Inside of this function, we will set adjacency matrix at I, j to true, and adjacency matrix at j, I to true. Let's define a removeEdge function that takes in three parameters: self, I, and j. Inside of this function, we will set adjacency matrix at I, j to false, and adjacency matrix at j, I to false. Finally, we will define a function named isAdjacent that will take in three parameters: self, I, and j. Inside of this function, we will return adjacency matrix at I, j. In the next lecture, we will learn how to represent a graph as an adjacency list in Python.